Cast Resin Bus. Introduction. With the development of epoxy resins as an insulation material for the switchgear component and the establishment of busways as a viable alternative to bus ducts in certain areas of application, it was but natural to explore the possibility of developing a cast resin bus for low and medium voltage applications. While the application of busways is limited to its usage in low voltage distribution, Cast Resin Bus offered an opportunity to extend its application to medium voltage distribution. The need was driven more for making Cast Resin Bus with the following desirable features. Maintenance-free, a higher degree of protection up to IP68, immune to corrosive and hazardous atmosphere, resistant to ultraviolet radiations, underground installation in trenches or buried and avoid elevated road crossings, fire stop, up to 3-hour rating as an inherent feature, self-extinguishing insulation, and is halogen-free, non-flammable, and emits no toxic gas. Most compact for medium voltage. Higher tolerance in sight joints up to 6 mm, ¼ inch. Cast resin buses have most of the features attributable to busways. Despite being more expensive than bus ducts and busways of similar ratings, they are preferred in projects that require a higher degree of environmental protection. Cast resin buses are manufactured with embedded copper or aluminium conductors. They are manufactured up to a rating of 6,300 amperes with copper conductors and 5,000 amperes with aluminium conductors for low voltage applications. They are also manufactured up to a rating of 3,000 amperes with aluminium conductors and 4,000 amperes with copper conductors for medium voltage application up to 36 kV. Unlike in busways where the conductors are wrapped or coated with insulation and pressed together along with the enclosure, in a cast resin bus, there is a specific gap that is maintained between the conductors, to be filled in with resin for insulation. The gap size will depend upon the insulation level of the cast resin bus. For higher rated voltage, individual phase conductors are separated by a significant distance, tied to the adjacent conductor by resin tie rods at strategic locations and cast together. The heat generated by the conductor is conducted across the resin and dissipated. Cast resin buses are of a comparatively recent development. The product has been accepted for specific projects. There is not much data available on its aging and life. Description. Cast resin bus can be broadly categorized based on the service voltage. For application in low voltage, less than 1 kV. For application in medium voltage, more than 1 kV and up to 36 kV. Presently dedicated governing specifications for cast resin bus do not exist either in ANSI/IEEE standards or IEC recommendations. Nevertheless, the following may be used as guiding documents. ANSI/IEEE 37.23 2015 for low and medium voltage bus ducts. IEC 61439 Part 6. Year 2012 for low voltage busways. IEC 62271-201. Year 2017 for medium voltage bus ducts. Encapsulating a conductor in resin, which is subjected to varying temperatures during normal operation. Due to load and ambient temperature variation, and abnormal operating conditions such as short circuit, throws up challenges. Compared to metal, resin is not a good conductor of heat and its thickness must be kept to a minimum to reduce the temperature gradient across the thickness of resin between the conductors and between the conductor and outer surface of the resin. Voltage withstand capability increases with the increase in the thickness of resin. When a conductor, copper or aluminium, is embedded in resin, there will be a differential expansion with temperature variation due to the difference in the temperature coefficient of linear expansion. If the interface does not cater to the differential expansion, it will generate stress. Cast resin bus installed outdoors and directly exposed to ultraviolet radiation may be cast in cycloaliphatic resins or protected against direct exposure to sunlight by a well-ventilated aluminium enclosure. Insulation Class B or F are used for casting the conductors and they meet the temperature rise requirements stipulated by the governing standards. Low-voltage cast resin buses are manufactured up to a rating of 6,300 amperes with copper conductors and 5,000 amperes with aluminium conductors. Manufacturers have tested them for a short circuit withstand capability of 100 kA RMS for 1 second and 220 kA peak. Copper or aluminium conductors are kept at a predetermined phase spacing and resin mix is poured in the annular space under vacuum to provide the necessary insulation. For ease of fabrication and assembly, the spacing is kept in a manner so that a straight conductor, coming out of casting, will align with the fish plates of the site joint assembly. For the low-voltage cast resin bus, the phase spacing will be more than one conductor thickness to accommodate the fish plate and insulating barrier plate at the site joint. A low-voltage cast resin bus can have several conductor configurations depending upon the system parameters. It is advisable to have an embedded protective earth conductor running along with the phase and neutral conductors. This will provide a low impedance path for the earth fault current. For higher current ratings, it is a norm to provide up to 3 parallel paths for a single connection. There are several alternatives to achieve this objective. The parallel conductors can be embedded in a common casting, stacked either horizontally or vertically, or cast individually and run alongside. Note the configuration of the conductor for ease of paralleling at the terminating end when stacked horizontally. Some data centers require a neutral conductor that is double the size of the phase conductors due to high harmonic contents. Low-voltage cast resin bus does not require a dedicated metallic enclosure. Protective earth conductor may be cast, or external earth may run along the length of the cast resin bus to provide a low impedance path for a ground fault current. When a cast resin bus is installed indoors, a site joint assembly makes the connection between the two adjacent sections. The joint is boxed in a site-assembled, insulating box. The mating surfaces of the box and cast resin bus body are sealed with a gasket to deliver the desired degree of protection. These joints can be accessed and maintained. It also helps during the installation and removal of sections where there are space constraints for the movement. When a cast resin bus is installed outdoors, the site joint can be carried out by bolting the factory-made fish plates and encapsulating it with a resin compound by a process similar to cable jointing. It also provides some flexibility in compensating for minor variations in length along the axis of the cast resin bus during installation. Standard elbows, bends, tee-offs, transpositions, tap-offs, and termination ends are available for various current ratings. A few manufacturers find it convenient to have all bends cast at the site for ease of installation. Several manufacturers have both busways and cast resin buses in their product range. They can offer a hybrid combination of cast resin bus and busways for a cost-effective solution. Cast resin buses, with a degree of protection of IP68, are installed outdoor, while busways with a degree of protection of IP55 are installed indoors. Special site joint assembly connects them indoors. Medium voltage cast resin buses are manufactured up to a current rating of 5000 amperes with copper conductors with a short time rating of 80 kA RMS for 1 second and 170 kA peak. The product is manufactured to 2 different designs depending upon the rated voltage: monoblock and segregated block. Monoblock. In monoblock design, the construction is similar to that of low voltage cast resin bus. These are manufactured for a rated voltage up to 12 kV. The phase spacing at the exposed ends of the conductor, for terminations, increases with the increase in the rated voltage. Monoblock designs become expensive for rated voltage above 12 kV. Segregated block. In a segregated block design, it becomes economical to space the conductors apart, according to the rated voltage. Depending upon the fault withstand capability, tie connections are envisaged at predetermined spans. The 3 phases and the tie rods are cast together to form an integral piece. Such a configuration has several advantages: reduces voltage stress on the insulation, saves the quantity of epoxy and is hence economical, makes the cast resin bus light, makes heat dissipation more efficient, thereby enabling a higher current rating. A well-ventilated aluminium enclosure can be fixed to the cast resin bus to protect it from damage after installation, contain the stray magnetic field within the enclosure which acts as a shield, provide weather shield when located outdoors, above ground, facilitate the installation of resin cast assembly on the support structure, facilitate the installation of an external earth bus on the enclosure. The reactance of the conductor will increase with the increase in the phase spacing. This is not of much consequence in a medium voltage cast resin bus. 2 adjacent sections of the cast resin bus are joined by fish plates. Here also there are 2 options for the protection of the site joint. The single-phase site joint can be boxed in an insulating cover when installed indoors. It can also be encapsulated in an epoxy component at the site, using techniques adopted for cable jointing. Standard bends, elbows, tap-offs, and termination ends are available for various current and voltage ratings. Mr. Balachandran graduated with a bachelor's degree, B.Tech, in electrical engineering from the Indian Institute of Technology, Madras, India, in 1967, and obtained a master's degree, M.E., in power engineering from the Indian Institute of Science, Bangalore, India, in 1970. He is a Fellow of the Institution of Engineers, FIE-India, Fellow of Institution of Engineering Technology and Chartered Engineer, FIET-UK, and Life Senior Member of the Institution of Electrical and Electronics Engineers, IEEE-US. He was the founder-director of Power Gear Limited and Busbar Systems, India, Limited. He has worked in manufacturing industries in India and the UK and is currently an advisor. He has engineered several busbar systems that have been manufactured and installed in various countries, including isolated phase bus for the largest hydroelectric power plant, 26 by 800 megawatts, at the Three Gorges project in China. During his professional career, he has developed and tested a range of bus products and their accessories. His area of interest also includes switchgear, instrument transformers, and power system analysis. The book, An Introduction to Busbar Systems, authored by V. Balachandran, is case-bound, hardcover, size A4, 386 pages, printed on 100 GSM glossy paper. Copies of the book can be purchased with a requisition to Bala at busbarsystems.net. Black and white version of the book is for sale in India, Afghanistan, Bangladesh, Bhutan, Nepal, Pakistan, and Sri Lanka at a cost of 4,500 Indian rupees plus freight. Color version of the book is for sale in all other countries at a cost of US $126.00 plus freight.